All right, in this last video for this module, we're going to be going through example 3.2 and making sure that you understand all of the examples that he's given you as far as drawing the dot structures and looking to see what the orbital hybridization is and to determine what the molecular geometry is. Okay, so example 3.2, the first example that he gives you is BF3. Now, you have to be careful with this one because remember, boron is an exception to the rule. Even though boron is in one of the first two rows of the periodic table, even though it is a non-metal, it is still one of these that does not really want to have 8 electrons. It doesn't want an octet. It only prefers to have 6 electrons around it. So we need to be cautious of that when we're drawing the dot structure. So if I look at BF3, boron has 3 valence electrons. Each fluorine has 7, and there are 3 of those, so that makes a total of 24 valence electrons. Again, boron is less electronegative than fluorine, and so boron is going to be my central atom. So if I join the fluorines to it, like this, so there's 2, 4, 6 valence electrons, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, so I've used them all. Boron has 6. It's happy with that. So this is the final dot structure. If I look here, I have 1, 2, 3 items around it. That means that this is going to be sp2 hybridized, and that is going to give it a trigonal shape. Okay. The next one that he has you look at is ClF4+. Okay. So chlorine is going to have 7. Each fluorine is going to have 7, and there are 4 of them, but it's got a positive charge on it, so I have to take away one of those electrons, and so that's going to give me 34 valence electrons. All right, so chlorine is going to be central, so I'm going to join my 4 fluorines around it, and that's going to be 2, 4, 6, 8. Now I'm going to start adding in these other electrons. So I've got 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So I got 32. I need 34 valence electrons. The extra lone pair will go on the chlorine. Hybridization. I've got 1, 2, 3, 4, 5 things around it. So the electron geometry is a trigonal bipyramid, but one of those has been replaced by a lone pair. And so what that means, that even though I have sp3 D hybridization, and again, the electron geometry is a trigonal bipyramid, but because this is a lone pair, this is going to be seesaw geometry. So again, if you kind of look at that, these 2 pieces kind of sit down here, and then here's your seesaw that would kind of tip back and forth like that. The molecule doesn't operate that way, but it's the picture that you can put in your mind of, you know, here's your seesaw. All right. Now, because this was an ion, we also want to make sure that we put brackets around it and put a plus up there to show that it had a charge on it. All right. The next one that he gives us is PCl6 with a -1 charge on it. So phosphorus has 5 electrons, 5 valence electrons. Each chlorine has 7, and there are 6 of them. And I need to add 1 more electron for this charge, and that's going to give me a total of 48 valence electrons. Okay? So I've got 48 valence electrons. Phosphorus is going to be in the middle. So I've got 6 attached to it. Okay, so there's 6. That means I've got 12 valence electrons shared already. So 12, I'm going to start adding lone pairs now. So I've got 12. 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48. So that one worked out perfect. I didn't need to add any more to the central atom. We want to make sure that we put brackets around this, put a negative charge up here. This the phosphorus has 6 items around it. And so that means that it's going to be sp3d2 hybridization. And I don't have any lone pairs taking the place of any of those. So this one is going to have an octahedral shape. Okay, last example. BrCl4 minus. Okay, another ion. So bromine has 7, chlorine has 7, and there are 4 of them. Plus I have 1 more electron due to the ion. And so that is going to give me a total of 36 valence electrons. One more time, the bromine is going to be central. I'm going to put my chlorines on here. Okay, and then I'm going to start adding lone pairs. So far I've got 2, 4, 6, 8 electrons, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So I'm up to 32. And so the rest of the lone pairs are going to have to go on the bromine. 34, 36. So I've got 2 extra lone pairs there. Again, put brackets around that, put a negative sign up there. How many items do I have around the bromine? Well, I've got 4 bonds and 2 lone pairs for a total of 6. So that means that this has to be sp3d2 hybridization. The electron geometry is octahedral, but I've got 2 lone pairs in there. And so what that means is that this is actually going to be square planar. What happens with this one 3-dimensionally is that these electron pairs want to get as far apart from each other as possible. So if I were going to draw this, give myself a little bit of space here. If I were going to draw this 3-dimensionally, what happens is this. 1 electron pair is going to go up here. 1 electron pair is going to go down here so they get as far away from each other as possible. And then my chlorines are actually going to be like this. Again, if I draw it in 3 dimensions. So remember, these chlorines, I've got 2 of them back behind the board, 2 of them up here in front of the board. So it's cutting through the board like this. And so 2 chlorines in front, 2 chlorines in back. And then these guys are on the top and the bottom. So if I draw it that way, it's a little easier to look at it and say, oh, okay, they're all in a square. So then they're all in the same plane. So it's square planar. Okay, so those are the 4 examples from example 3.2. And now you can go get some more practice.